Okay, this is Zach Mullins again. I'm back talking about the Opportunity Mars rover and its supporting infrastructure as part of my risk and reliability analysis. Today is the FMEA report, or failure mode and effects analysis. This takes individual systems from within the system and applies 3 ratings to them to determine their risk priority index for various failure modes. This analysis reveals where the weak points and most risky chances of failure are for this system. The first of these rankings is the severity ranking. This determines how large of an effect this failure mode would have on the system as a whole. For my analysis, I used this 10-point scale, which comes from NASA's Academy for Aerospace Quality. We see that the top 2 rankings cause complete system failure, with and without warning, working down to no discernible effect. We'll note that 3 and 4 rankings do represent full loss of system functionality for a period of time, but in such a way that the system is recoverable and can be repaired. The second rating is for occurrence. This is the likelihood the failure will occur. We go from an almost certain % chance to basically impossible. Don't count possible as an option. Finally, the detection ranking ranks how easy it is to predict this error, see it coming, and possibly prevent its subsequent failure mode before it develops into a true failure. We go from having no ability to predict this to almost certainly we will catch it. As such, this scale is inverted in a way from the prior 2 scales. This allows us to then multiply all 3 rankings together evenly to create a meaningful number to represent the scaled risk of a certain failure mode. Here we have the failure mode and effects analysis. We break first down by each subsystem within the overall system, as discussed earlier: the control center, the Deep Space Network Station, the Mars orbiting satellites, and the Opportunity rover itself. This is then broken down to the subsystems within each of these subsystems and their potential failure modes, each of which has a cause, an effect, and a method of detection, which are then rated by the ratings we discussed earlier. We see that the 2 greatest areas for failure in red here, 200 for the hardware failure of the onboard computer for the rover, and failure of the in-situ instrument suite, make up the top 3 possible failure modes for our system. Others of note are the failure of the navigation and hazard cameras on board the rover, and all the way at the top we see 96s for software failures on the ground center, or the control center, and the Deep Space Network ground station. These are mirrored by several factors beyond control, including power outages, which were rated to be virtually undetectable from our system, but not very severe, giving them an unrealistically inflated value for our purposes. Human errors also contribute significantly to our system, as predicted rather weakly by current methods. The lack of attention, human oversight could cause dangerous commands to be sent to any element of the system, resulting in a failure. Again, you see a great deal of the spread is focused more in the range of 10 to 60, with our predominant outliers in the 100 to 200 range. That's all.